Hello everybody. In this video we're going to have an introduction to another type of sequence. It's called a geometric sequence. And some of the notation will work the same, so this won't be as new as the arithmetic rollout because we're going to use the same notation but a different idea altogether. So let's get into this and look at the definition and just see where we get. I'm going to do some harder examples in another video, so there won't be but two just to get this thing rolled out here. Oh, wrong page. Okay. All right, so this is in the lesson notes about geometric sequences. This is 1.3. So another type of sequence we have to learn. So far we know about arithmetic sequences. They're a plus sequence or a minus sequence, adding, you could say. But this one is called geometric, and in words, a geometric progression, which is what this is, also known as a geometric sequence, is a sequence of numbers where each term after the first is found by multiplying. So there's the key difference. The previous one by a fixed number called the common ratio. All right, so I put an example down here. And you can see a big difference in this in the arithmetic sequence is we have to multiply by something each time to get to the next term. So 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81, and so on. Okay? Note that if you look for a common difference here, 9 minus 3 is 6. 27 minus 9 is not 6. So this is definitely not arithmetic when you run your test. Okay, and then if we come over here, we can see that you can have a negative. Oh, by the way, the notation here, they don't use D anymore because that would be too confusing. It's not a common difference. It's a ratio. And before I go to the next example, let me talk about this ratio part. And the reason they use a ratio is, okay, go back to your arithmetic. Remember, you find the common difference by subtracting a term by its preceding term. Well, in geometric, you divide a term by the preceding term. So 9 divided by 3 is 3. 27 divided by 9 is 3. And that's how you find a common ratio. And you can see they can have negative common ratios. This is a multiply by -4 sequence. 1 times -4 times -4. Notice the signs are alternating. That's what they call it. Plus, minus, plus, minus. And that's called an alternating sequence, actually. And now you can see that you can get a negative common ratio. Negative 64 divided by 16 is -4. All right, so this is how the geometric sequence works. And in this video, I'd like to get these couple skills out of the way. First thing first is how to identify a geometric sequence. And to do that, you have to divide all the terms. All right, so let me just write my sequence up here at the top. And what was it, 128? No, 256. 128, 64, 32. Now, technically, you have to test them all. So I'm going to divide 128 by 256. Turns out that's 1/2. Divide 64 by 128, 1/2. And notice if I multiply by 1/2 of 256, I get the 128. 128 times 1/2, I get the 64, and so on. And I know 32 divided by 64 is also 1/2. So this is a geometric sequence. Okay, that's how you tell. The next sequence on this page, and let's go look at it right quick. So we identified this as geometric. We come down here and we're given another sequence. And even, I'm not, just so I don't use up so much time, if we started looking at this, 13 divided by 4 is not the same as 22 divided by 13. It's not. So this is not geometric. In fact, this is arithmetic, isn't it? 13 minus 4 is 9. 22 minus 13 is 9. 31 minus 22 is 9. So this is actually arithmetic. This is not geometric. Now, they can be a neither. So, but no one's asked for that in these problems. It just says identify geometric sequence. So this is not geometric. That one is. All right. So another skill we're going to need is finding the terms. Find terms of a geometric sequence. Just like we did with arithmetic, we need to be able to predict terms, and they always start us off by predicting like the next 3. Okay, so if I'm looking at my sequence here, 1, -4, 16, -64, I need to find the common a common ratio, sorry. So I got 1, oops, don't want that. 1, -4, 16, -64, and we need to find the next 3 terms. All right, so what they're asking for, they want f of 5. Remember, that's going to be your 5th term. All right, so first we need to find out what the common ratio is. Well, now here's something I want to point out. We know it's geometric. Divide the easiest place, and that's -4 divided by 1. So we know it's -4, right? So f of 5 is -64 times -4, which is positive 256. So that's the 5th term. The 6th term, well, we can just start putting those in now, is 256 times -4. And that turns out to be -1024. F of 7 is -1024 times -4. And it goes on just like this. Okay, so this gives me what, 4096? And that's how you would find the next 3 terms. I use that notation just to kind of you got to get used to seeing it. So that's the n equals 5 term, n equals 6, n equals 7. Those are your next 3. Okay. And we got one more here, and this will be the end of this video. We are told to find the next 3 terms. This time, I do want to warn you about this one. This one can be tempting to do some things that people do out of convenience that are wrong. So we're given a sequence like this: 9, 3, 1, 1/3, ... Okay, so if we're going to find the next 3 terms, we want to find the common ratio, and we find that by dividing a term by its preceding term. And don't make it convenient for yourself and divide the wrong way so you get a whole number. That some people do that. They'll divide the opposite direction, and they're going to get the wrong common ratio. Again, an easy spot to divide is right here. 1/3 divided by 1 is 1/3, or just 1 divided by 3. So you don't work too hard for that common ratio. There it is. Okay? And again, this is the 1st, 2nd, 3rd, 4th. So we're looking for f of 5. Well, we know we need to multiply that 1/3 by the common ratio, which is 1/3. And last time I checked, that was 1/9. F of 6, well, that's going to be 1/9 times 1/3, right? And you'll get 1 over 27. F of 7, one more time here, 1 over 27 times 1/3. See, I'm just multiplying by that 1/3 over and over again. And you get 1 over 81. All right, y'all, that's the basics, and that's how these things kind of start off and work. Give it a shot. I'll fill these notes in with what we've done. And I'll see you in the next video where we're going to look at an nth term formula. So I didn't want to make this one big long video, so it'll be chunked. All right, I'll see you in the next one.